Hello, my name is Nitin. Almost every year, smartphones are equipped with new frequency bands. Yet, the real estate available for placing antennas remains the same. At the same time, testing demands are increasing with new compliance requirements right in touch with the phantom surface. Array systems are ultra fast, but they are limited to resolve sharp field distributions. Spiag addressed this challenge with a feature called Extend Combiner, which virtually increases sensor resolution by combining multiple measurements at different locations. The downside, Extend requires more than 15 random measurements. The software must co-register each of these 15 SAR patterns to determine the shifts before they can be combined. To make things faster and simpler, Spiag developed a new combiner called X4 Combiner for the Daisy 3D system. X4 uses well-defined shifts and does not require any co-registration. As a result, you get high accuracy with far fewer measurements. Even better, this feature is now available in cSAR3D version 5.10 for manual use via the API version 2 as demonstrated next. This marks a big step forward in both testing speed and accuracy. Today, I will demonstrate this powerful feature by measuring this mobile phone at 6.5 GHz in the Wi-Fi 6E band. To achieve the precise shifts needed for the X4 combiner, a special frame is required which makes it possible to apply these shifts with the necessary accuracy. The frame fits the cSAR3D, and to test the top edge of this phone, I 3D printed this custom holder. First, I will set the device under test into the test transmitting mode. The new cSAR3D version 5.10 has a cool new Lilies format that is more readable and refreshed. The X4 combiner is currently only available using the Application Programming Interface or API. To use it, open the sample Jupyter notebook that is pre-installed with the API tutorial. This small code snippet here runs the X4 measurement on Wi-Fi 6E at a frequency of 6425 MHz. As you can see in the script, there are 4 predefined offsets which correspond to the 4 test positions of the DUT holder in the frame. I run the script and this starts the X4 combiner. I move the device to the 4 positions one by one. At the end, the X4 combiner completes the measurement and computes the combined measurement. The deviation is only 0.3 dB compared to the reference measurement with Daisy 8 module SAR, while the single measurement varied between minus 1.09 and plus 0.96 dB. This aligns with findings from a comprehensive multi-source validation campaign demonstrating that single measurement variability for extremely localized sources can be reduced from over 2 dB to below 0.8 dB. The variability for testing the edges of phones at 0 mm distance is reduced to typically less than 10%. There are more improvements in version 5.10. It is now possible to scale any individual test case with a scaling factor. This feature is very helpful, for instance, when combining 5G NSA LT and NR test cases with dynamic power sharing. The power during specific absorption rate measurement is not the same as the power during non-standalone simultaneous transmission. The LTE and NR results can be scaled before combining to get accurate SAR exposure values. The new version 5.10 also allows us to combine time average SAR test cases and non-task test cases. In summary, the new cSAR3D version 5.10 introduces the fast and precise X4 combiner. Another major improvement is that cSAR3D now advises users when X10 or X4 is needed to obtain reliable test results. This is for configurations where the field absorption is too sharp for the sensor array and the uncertainty cannot be adequately determined. In such cases, single measurements often show large variations and the software helps to flag that. Other important features include measurement scaling, combination of task and non-task test cases, graphical user interface improvements to the Lilies, along with several others in the application programming interface. New application notes have also been added to the manual, showing interfacing of the API with Mac operating system. Thank you, Shpyag, for this new and important software release. Thanks for watching this video.